Hello and welcome to this presentation on metric-driven documentation. My name is Chris Noonan. I'm a staff technical writer in a company called Rebely. I like guitars, music and hiking. And the guy on the left there, that's John Hannagan. He's a senior developer. He likes motorbikes, travel and Vegemite. We both work for a company called Rebely. Rebely is a payments orchestration platform. It also does subscription billing, KYC and lots of cool other stuff. Check us out. About this talk. So this talk is for anyone who creates or manages technical documentation and is interested in gaining insights and metrics into that content. It describes our journey using a readability metric on our docs, and we've been using these for about 2 years. We've been using these to fine-tune our content and learn from it, so we'd like to share these insights and learnings with you. We also created an open source tool, and we'd like to share that with you as well. So why did we do this? Why do we use readability metrics in our docs? We wanted to reduce the cognitive load that we were placing on the reader. Cognitive load is the amount of processing power that you're expecting your users to use when they read your documentation. And they already have a lot going on. So for example, if we think of a support agent, they're encountering an issue with a product, they have to access long-term memory. So for example, they're trying to remember how they resolved similar issues in the past, and how they resolved it, who they spoke to, points of contact possibly, lots of stuff. They're also accessing short-term memory, so like what they've done already, what commands they commonly use, etc. They're also like searching internally on their own software. Maybe they're searching tickets to see if someone's encountered the same issue and what they did to resolve it. And maybe they're also Googling, and they may be also looking at docs. So that's a lot of sensory input. The cognitive load is quite high. So then they need to go to a website, they do find a link to something or they find some technical documentation. Their cognitive load is already high, so the last thing they want is some very complex writing to read. They want it to be as easy to understand as possible, and they want to get the information quickly and resolve their problem, they want to resolve it and end that issue so they can move on to something else and reduce their own cognitive load. It's difficult to measure this. We wanted to create a metric to measure how complex it is to read our content. In short, we don't really have an accurate way of measuring that in technical writing. We can use things like surveys, we can test our users, we can ask them to read out loud, UX principles. So they'll interact with the product, we give them a procedure, we kind of monitor them, ask them to speak out their thoughts, and we can take notes and gain insights from that. And we can also monitor maybe customer support agents' tickets relating to docs, and we can see if the number is increasing or decreasing and direct feedback from the customer. So we can tell if there's a problem in the docs, but we can't always tell how easy it is to read. And a metric like this, it's very interesting for us. At the time, we were doing a major overhaul of the docs. So I just joined Rebely at that stage. It was 2 years ago, but they hadn't had a technical writer before me, so they didn't really have a lot of docs, and what was there didn't really use a style guide. So we needed to rework what was there and really build out the docs side. So there was quite a lot of documentation to be made. It was a good opportunity here. It was quite a clean slate, really. And we also wanted to reduce the cognitive load that we were placing on the reviewer. This isn't really something that people mention a lot. But in Rebely, I'm the only tech writer, and most of my reviewers are developers. They're all very busy. They've all got their own issues and tasks that they're trying to resolve. They're all working on stuff. I want to make that process of reviewing my work as easy as possible. I want them to possibly enjoy it, and I don't want to be a burden. And I also possibly was looking to refine my own writing. Metrics like this could give a good indication on how I can improve certain things, or possibly spot little issues that could be refined. So why do we make a tool? As you probably gathered from the previous slide, we saw great potential here. It's a great potential indicator of complexity. And in Rebely, just as in any company or every tech writer, we strive to create the best experience possible for a reader and their user. So we want people to use our product, and we want people to enjoy using our docs. We want people to refer others to our product and our docs, and we want them to have a nice experience while they're there. We shouldn't be making content that's hard to read and a stressful scenario for our user. We want them to enjoy it. And yeah, this was a good opportunity to measure that. We couldn't find a tool that gave multiple readability metrics on Markdown. It was important to us to have multiple metrics. It's something that I've been interested for quite a while, and even before I started in Readbilly, I had looked at these kind of tools. There are some out there, but so for example, if you think of maybe Grammarly, it uses a different type of content management system, and you have to pay for it. It is a good tool, but it's not ideal for this kind of work. And also, it's basically one metric. We needed as much data as possible. We wanted to conduct a good experiment, and we wanted to determine, okay, if this is something useful, can we actually use it, and how can we use it? So we needed to actually build this from the ground up. The possible advantages of using a tool like this are readability metrics in general. So they reduce the cognitive load that we place on the reader. They can help reduce the cognitive load that we're placing on the reviewer, as mentioned earlier. And they also help make our content easier to translate. Some of these readability metrics use common word lists. And common word lists, if you put words in your documents that aren't commonly used, so for example, words that aren't commonly used in language or in media, it'll find it hard to interpret those, and it will give you a poor reading. And similar in the translation words, these words are sometimes referred to as fuzzy words. They may not fit exactly in a sentence and they're hard to interpret. These can increase translation costs, and they're also hard for maybe non-native speakers to understand because they don't quite fit in the sentence. So it does help you find these, and it helps you to avoid them. It also helps keep the writer's use of language in check. I'm the only tech writer in Readbilly, so tools like this give me a good insight into, how I can improve my writing, or maybe bad habits that are creeping in. Also help when making writing style decisions. So we have our own style guides, as many companies do. And when making style decisions, it's usually on the basis of, you explain why it's better to do it this way, and you use like logic behind it. But it's nice to have a metric there as well to say, if we do it this way, readability generally increases by X amount, or alternatively, if we do it this other way, readability metrics interpret that poorly. So it is a good indicator. And also helps to convey improvement in readability over time. So as mentioned earlier, it's difficult to determine over time whether or not the changes you're making style-wise really are making that experience easier for the user, and perhaps this is a good indicator of it. So how it works in Readbilly, we use a Docker code workflow using Markdown, GitHub, and also Redocly. We added a GitHub action to report readability scores on our docs repository. So each time you make a change to a file or a number of files, you make a pull request, and inside that pull request, the readability reporter scores each change in each file. So you'll have an overall score for each file. It tells you the degree of readability increase or decrease per file, but also the overall doc set, how the changes you made to those files impacts your overall readability score. And it's important to state, I suppose, we didn't use these as a concrete measurement. For us, it was like an indicator. So like if a document scored poorly after a change, it wouldn't be a blocker, but we would look to see, okay, why is that scoring poorly? Can we improve it? If we can, we will, and if we can't, that's a different story. But it's not a blocker, that's the important part. It doesn't hold up work. We tweaked the text to get higher scores, as I mentioned, so if we could tweak it, we did, and it did give us higher scores. We monitored the scores for each metric for a period of 2 years, and we use the scores to indicate the readability of our docs over time. So here's some findings from our experiment. Technical writing principles work. That's not really a big revelation, but it was really interesting to see how they worked and why, and actually have a visual indication for the degree of change as you wrote those docs. As you committed your changes, you actually saw that, which was really cool. It's quite similar to debugging, so it's like debugging your docs. So straight out of any Good technical writing style guide here. Here's the guidance. So writing simple and concise sentences provide good readability scores. And a rough guide here of complexity is the number of syllables per word and the number of words per sentence. So if you can keep the number of syllables low and the number of words per sentence low, you're onto a winner. It's going to be really easy to read and understand that. Readability metrics are a good indicator of cognitive load. You can actually see this. So like if you find something that you find hard to read and you copy paste that in, or you put it through the tools, it'll give you poor reading. And if you find something that's really easy to read and put that in there, like the comparison is really obvious. So it's interesting to work through and refine it yourself to see how you can tweak complicated content into something that's easier to read without losing the meaning, of course. These metrics don't work well on single sentences, so that's one good point to mention. The algorithms behind these metrics just aren't designed to process single sentences. So here are some guidelines based on what I learned during this experiment. Simple words and concise sentences. So again, straight out of any good technical writing style guide. Avoid using longer words where short and more simple words suffice. Try to keep syllable count low per sentence. Avoid verbose descriptions. And this last one's quite important, I think. Avoid academic style writing and jargon. So I work in the software industry, and I'd imagine a lot of you do as well. So kind of a byproduct of that is a lot of us go through academia, and we spend a lot of time there. And in academia, there are writing requirements. So your submissions need to be a certain number of words in order to be accepted. So for example, say a thesis may need to be 25,000 words. And therein lies the problem. So we're taught to write in a very verbose way, and we would probably be punished, or we get a bad rating or a bad result in our thesis if we make that really concise. If we made a really concise thesis, it may not even be accepted. But tech writing, if you want someone to understand something, try and avoid this academic style. You kind of have to unlearn it. It's something it took me quite a while to do. But that's kind of the secret in this writing, is to try and avoid that academic style and keep it simple. And finally, jargon. So this relates to what I mentioned earlier around translation. Jargon is very specific to certain areas, so it might be very specific to finance or sales or other areas like that. Not everyone might be familiar with it. So this is the type of language that will end up on that fuzzy words list that I mentioned earlier. So it's complicated to translate, but also if you're writing in English, maybe non-native English speakers will also find that difficult to understand. Even if these words are real words, where they're placed within a sentence and how they're phrased can be very unusual at times. So avoid those. Here are some examples based on the findings. Again, straight out of any good technical writing style guide. Avoid passive voice and use active instead. So in the active voice, the subject receives the action, whereas in the active voice, the subject of the sentence performs the action. Here's a passive example, and you're going to notice straight away when I compare these two how complex the first one is. In this first one, the subject receives the action. So the card holder's bin is associated with a different currency than the payment currency. I find that quite hard to understand, and the first time I encountered this, I didn't actually write this one myself, I found it, but I had to read through it maybe twice, maybe even 3 times to understand the components in the sentence and to actually figure out what it was saying. And the reworked one here, where the subject of the sentence performs the action, the currency associated with the cardholder's bin does not match the payment currency. This change resulted in a readability increase of 4 points, which is quite substantial within the readability metric scale. Avoid future tense. These are generally much longer sentences, and you can see it here in the future example. So after you have created your account, you will be able to start using the service. And in the reworked version, using present tense, after you create your account, you can start using the service. This resulted in a readability increase of 2 points, which is also quite substantial. So avoid using unnecessary words. We have a tendency to do this. I know I do sometimes as well. Avoid adding words that don't add to the meaning of the sentence. So like the top example here, the bad one, appended data is added to the bottom of the current data set. And the reworked version, appended data is added to the bottom of the data set. So the word current in that first example, it's really not needed in there, and it does make the sentence more complex. By removing that word, it resulted in a readability increase of 5 points, which is huge. So finally, my last example here, avoid anthropomorphism. So anthropomorphism is the assignment of non-human traits, it's the assignment of human traits to non-human entities. So for example, in this bad example here, the dashboard is a non-human entity, and we have assigned human attributes to it. We're saying that it can allow you, a person, to do something, which obviously it can't. So the dashboard allows you to view, measure, and analyze payment data. And the reworked version, use the dashboard to view, measure, and analyze payment data. This resulted in a readability increase of 1.34 points, which is quite big. This may seem like a smaller number compared to the others, but when you take into account that someone may have hundreds of files, or maybe even thousands of files, lots of documents, lots of text, if you really make a point of refining your text like this, it'll result in a big overall reduction in complexity. And also, anthropomorphism is also very difficult for translators. It doesn't translate well. And that's it from me. Over to my colleague, John.
Oh, thanks, Chris. Hi, everyone. I'm John, one of the senior devs here at Rebilly. I'm going to talk a bit about the tool that we made to help with metric-driven documentation, which we named Lexi. Primarily, it's a GitHub action that reports the readability of your documentation on pull requests. So it'll give you a readability score, which is kind of a gauge of the complexity, as Chris was mentioning earlier. I'm going to go over what metrics we looked into and a bit about how they work, how we created a combined metric from those. And then finally, I'll talk a bit about the GitHub action and how that works, and I'll tell you where you can find it in case you want to try it out. So there were some existing metrics that have been around for quite some time, so often created around the 50s, 60s, and 70s. So these were created a long time before computers were really used, before software existed. So on their own, they're not really a great means of gauging readability for your technical documentation. And the way that these scores work is they all provide a value, which is kind of an estimate of the complexity of the text. Usually it's based on things like syllables per sentence, characters per word, words per sentence, and so on. Sometimes even how common a word is, so whether or not it's in like the lexicon of a high school student or not, is something that one of the metrics uses. So we tracked 7 of these common readability metrics that we found as we were making improvements to the documentation here at Rebilly. We found that only 5 of these really tracked consistently and improved over time. You can see those ones on the left. On the right, we found these ones, they actually didn't track, they didn't improve as we were making improvements to our documentation. I won't go into how each and every metric works because they're all really similar, but for some insight into one of them, for example, the automated readability index, well, that's a number that represents the grade level required to understand a text. So US grade level, I think between 4 and 12, and it's based on the average number of characters per word and the words per sentence. And the lower the score, the easier the text is meant to be to read, because the lower the score, the lower the grade level is required to read that text. Here you can see a graph of how each metric tracked over time as we were making these documentation improvements. You can see the 2 metrics in orange, although they do track upwards now, at the beginning they were actually tracking downwards as we were making improvements to our documentation. So for that reason, we chose not to include them in the final readability score because we think that we were getting enough value from the other scores as it was, and they were tracking in a much more consistent way. So once we had the 5 metrics nailed down that we wanted to use, we wanted to create a more simple way to understand them, so a single, simple readability score. Because having these 5 metrics is great, but they have confusing acronyms, and it's kind of very hard to understand what it means when you get these 5 scores back for your document. So we did create a weighted sum. We used a simple linear regression analysis using the start and the end scores for each metric. And from that, you can work out the correlation coefficients that we can pop into a weighted sum. So essentially, we can kind of identify how much each metric was contributing to the overall score and normalize the readability based on that. So what's the target score? Well, the score is out of 100, but you have to remember that it's a score that's a measure of complexity. So if you were getting 100 for a document, it would mean that you're maxing out every single metric of the 5 that we mentioned. And that would mean that your document would be really very simple, which is not necessarily what you want. So it would probably be oversimplified. So you really need to think about your target audience. Here at Readability, for our technical documentation, we found that a score between 60 and 70 seems to be a good target. So that's what we aim for here. So now that we have this combined score, I'll talk a bit about how the GitHub action itself works. Here's a really simple flow diagram showing what happens when you run Lexi on a pull request. So first of all, we take a bunch of the markdown files from your repository, then we run a bit of pre-processing on them, which I'll talk about next. And then we send them to the scoring system using the 5 different scores that we talked about earlier. After that, we then calculate the final weighted readability score, which is based on the 5 previous scores. And then we do the same again against the original files without your pull request changes. So this way we can get a difference value, right? So we can say that this either did or did not improve the readability based on the changes. And then we wrap it all up in a report that we post as a comment to the GitHub pull request. And you're easily able to see any regressions or improvements. So we do need to do some pre-processing before we send the text to be scored, because like I said earlier, the readability metrics, they're not ideal for technical documentation. So they're based more on text-heavy documents, large bodies of text, things like that. So it means not everything's really suitable in your markdown file for scoring. So things like short list items, table items, code, front matter, things like that, they're all going to show either false positive improvement or false negative impact on the score. So we do need to massage it a little bit before we score it. So we do things like we remove those items and we add periods to certain places and just to be able to get a sort of a more reliable readability score. So using the action is super simple. On the left, you can see what it looks like in a GitHub workflow. So you just need to check out the repository, then use Lexi, give it a GitHub token, which has at least write permission for a pull request, because it needs to be able to write a comment. And then you give it a glob describing what files you want it to analyze and report on. And then you'll see what the output is like on the right. So you get a comment, it'll give you the overall readability score. And then for each file in the pull request, it gives you a readability score, and you can see any changes, so any difference, improvement, or regression based on the changes in the pull request. So we also created a playground, which is helpful for providing like an insight into how Lexi is scoring a piece of text. So it's a interactive web app. It's hosted on GitHub pages. Really simple to get to. You can get to it from the repository and run it in your browser. And then on the right-hand side, you can enter your text. You can play around with it, remove things, improve, or do whatever you like there. And then on the left-hand side, you'll see the scores update in real time. And so on the top, you can see the readability score. And on the bottom is all the component readability indexes that add up to the readability score. You can also preview the text that it's processing. So in the bottom left, if you check the preview text checkbox, it'll show you what text Lexi is actually processing. So that can help you to debug or work out why your scoring might be a certain way. So that brings us to the end of our talk. Hope you've enjoyed it. If you'd like to try Lexi, you can find it on GitHub there. There's also a link to the playground. So thank you very much.
Well, thank you so much for joining us. We all really enjoyed your talk. And we have some questions. Actually, you all got a ton of questions, so many questions. People were very much wanting to know more. So let's see if we can get through as many of them as we can. Okay, so the first one, you talked a little bit about Grammarly and why Grammarly wasn't going to work for your company and your needs. Was one of the things that you were concerned about was the security issues for like basically who owns the text and kind of exposing the text to well, especially for anything private.
It wasn't one of my considerations or our considerations, but it's definitely a very valid point. You know, I'm not sure who owns that content once you put it into a tool like that, and especially if you're copy pasting it out into a browser. There's a lot of security issues around that.
Well, in their use section, their software use, I forget what they call that. Anyway, they basically say they own it.
Oh, yeah, that's a big no-no.
Yeah. So let's see. Let me go look and see what other questions we have.
Sure.
So were you able to measure any correlation between the readability of a given doc and its usefulness for your users? So readability is good, but how does it correlate with usefulness?
It's very hard to measure that. I suppose if you wanted to expand on this, you would incorporate more user feedback. So like this is like a measure of cognitive load, like so how complex something is to read, how big words are, you know, how many words are in a sentence, and what kind of a load that puts on the user. And this is an indicator, you know, it's not concrete, but from playing around with it for 2 years, we do see that it's valuable. We find it valuable and useful, so we're looking to share that. But as a way of measuring, like, you know, how effective it is to the end user or what their experience with it is, we'd have to go a little bit further in this experiment. Maybe that's the next step. Maybe next year we can make a talk on that one.
Yeah, that's something I look forward to. Do you have anything to add, John?
No, I just agree with Chris.
Super. So here's another question. Do you also consider content accessibility as part of your readability metrics? For example, what about is the content readable for people with dyslexia? I think that's a really good point.
Yeah, I think that is a really good point. Definitely like integrating more metrics into the readability score, it would be really simple. We would just need to know if there are any existing metrics that can kind of analyze that or not. And then we would obviously want to see that they work well as well. But it would be really simple to add things like that.
Yeah, I think that's a very interesting point. And exactly how would you measure it? How does that apply to readability? I think that's a great question. Let's see. Here's another one. So what's your feedback channel for these metrics?
So far, it's just all of our colleagues in Readability. So I think in total, we have about maybe 30, 35 people. All of our docs are through Docs code. So it's like our internal docs and also our external docs or APIs. We have a ton of docs. So far, it's just within Readability. We do also interact a lot with our end users and they give us feedback on certain things that they have issues with, but that's as far as it goes so far.
Well, have people noticed a difference?
Yeah, it's hard to measure that as well. Like we do, like since I started in the company, like people have said to us, you know, there's a big improvement. You know, I find it easier to find stuff, especially on our API docs. We put a lot of work and effort into those over about 6 months, just to make sure that all of the descriptions are accurate and there's info in them. But it's kind of subjective. It's like, you know, if you ask someone, you know, what's your experience and get them to say, okay, it's between 0 and 5. Mm-hmm. It's hard to derive meaning from that and make something actionable from it. That's something I'm thinking about, but it's a complicated one.
Yeah, especially when you're trying to measure the before, if you didn't have any measurement in place then to the after.
All we have really is the metric. That's pretty much it.
Okay, well, I have another question. Does this tool work on your markdown directly, or does it work on your processed output? So at what level are you doing the analysis?
Yeah, so we process everything to remove things that would really negatively affect the scores. So it works on the markdown files, but it will remove things like short header items, like code, things like that, and then it'll produce a readability score from that. There's also a playground that you can get to from the GitHub page. You can kind of put your text in, and on there's a toggle switch, and you can see exactly what text is being scored. Because there's always room for improvement, of course. So maybe some of the parsing and some of the removal of the text might not be working properly. That's why it's useful to be able to see what the scoring is actually based on sometimes.
Okay, let me see just a second. I do have a question as I look through all of your other questions. Well, actually, I'm not. Oh, here we go. What are the readability scores you are using for your repository? So basically, are you using Flesch Kincaid? Are you using some of the other types of scores? And it sounds like you're using grade level. Is that right? Or are you using other types of scoring?
So we started with all of the ones that we could find, which were like 7 different and they're listed in the README file. And we ended up keeping 5, like the Fleisch Reading Index, Gunning Fog, Automated Readability Index, Dale Chow, and the Coleman Liao Index, the pronunciation. But those are the ones that we ended up using. And there's 2 extra ones which we kind of knocked out because we didn't find that they tracked super well with changes that we thought were improvements.
Well, are you using the Flesch Reading Ease or the Flesch Kincaid grade level?
It's the Reading Ease.
The Reading Ease. Okay, well, that's good to know because that is a different score. I definitely have found when I was using readability checkers on my content, this is the question I have, that if you're doing something like procedures or bulletin list, you get really great scores. But when you're doing like a paragraph, that's when you really need to focus. Do you do that? Do you tend to focus on a paragraph, or do you just kind of look at the whole document?
It's the whole document. Sorry, John, you might want to say something there. The whole document, the reason bullets are good is because the sentences are shorter. You know, it's going to read them as kind of more concise sentences. They may not be, but they have a more positive result generally. But it's the whole document. Great.
Here's another question. How do you balance technical writing guided by the readability tool and preserving the unique tone and voice of the Readability brand?
A very strict style guide. I think it's important. When we review something, we're all reviewing. So like there's one tech writer and that's me, but everybody reviews, everybody writes. And like we're all strict on each other. It's not like there's like a good kind of code of conduct is to say like, you know, at the top, like it's a nitpick or like, you know, if it's a question, just describe what it is first and then describe your feedback in the comment. So someone's clear about what it is and why and point to the style guide. So yeah, the uniqueness of the guide really is that we don't have a unique tone. The style guide ensures we don't really have that. You shouldn't really tell that these are individual writers, that it's one. Yeah, maybe I said that in a strange way, actually. Yeah.
No, that's really well. That's really, you're really working for that one voice.
Absolutely.
And you feel like just with everybody reviewing each other's content, you're reaching that?
We're kind of learning from each other, and like we're being strict in that if something isn't exactly as the style guide says, we will say it to each other. And from that, like since I started in Readability, like I've seen people who had lots of bad habits from years of not really working with a tech writer into like, and now they've become, you know, they police me a lot, you know, and they pick up stuff I'm doing wrong, you know, which is great, you know. As a community, we're all learning from each other. I think that's very progressive.
Yeah, that's great. But just to follow up on the voice thing, and this is going to be the last question, just to follow up on the voice, what would you say the Rebilly voice really is?
Well, that's a big question. So, yeah, I don't think it has an individual voice. Like, I think it's more of like, yeah, that's a bit, it doesn't really have a personality behind it. I think when you're talking about UIs, maybe they can. Like, people expect the UI sometimes to act like a person, but I don't think the docs really have one.
Okay, well, thank you very much.